Good afternoon, everyone. On behalf of College, Department of CSE, Artificial Intelligence and Machine Learning, I extend a warm welcome to our respected principal, sir, head of the department, faculty members, dear students, and most importantly, our chief guest for today's session, Mr. Srinivasan Jayaraman, sir. Now I call upon Tarani from second year to deliver the welcome address and introduce our chief guest.
Good, af- Good afternoon to one and all present here. I extend my warm and cheerful welcome to this special workshop on From Code to Creativity, Generative AI in Modern Software Development. We are honored to have with us Mr. Srinivasan Jayaraman, Lead Engineer at Medbank, Cloud Certified Front-End Engineer, Founder AI Alchemy, Melbourne, Australia, with over 15 plus years of experience in software industry and a strong foundation in information technology from Anna University. He has made notable contribution in the areas of front-end engineering and emerging AI technologies. His journey reflects a rare blend and a technical expertise, creative innovation, making him the perfect guide for today's session. We look forward to gaining valuable insight from his experience and vision in applying generative AI to modern development practices. Once again, we welcome you, sir.
Without further delay, let us now invite our honorable chief guest, Mr. Srinivasan Jayaraman sir. We are eagerly looking forward to your insight. I request you to kindly take over the session, sir.
Cool. Thank you. Hope I'm audible to you guys. Yes, right? Yep, cool. Hello, everyone. I'm Srini Jayaraman. I'm the lead principal engineer at Medibank. I've been solving large-scale software challenges for the past 15 years now. I am now a founder of NAI Alchemy, a company. It's a turning wild AI ideas into real world systems. So over the past 15 years, I've had privilege working with a lot of clients like Medibank, ANZ, Pearson, solving really complex engineering problems. It's been wonderful to share my experience. And what's really excites me these days is actually experimenting these generative AI, not just as a coding tool, but actually as a creative companion. So that's why I'm here today to share about what this generative AI is actually doing and how it's reshaping the entire software industry, and how the next generation of engineers like you, who actually can blend the code with creativity. Um, can you guys actually see my screen? Is it all visible? Can you say, yeah, say one in the chat, or something like, can you just, I'm not seeing your screen, so are you guys able to see my screen? Yep. Cool, thank you, thanks for pressing the one. So that actually helps. um, so what, I'll just start with a little bit of basics, I know, here and there, but I want to make it more engaging. So over a course of time, I'm gonna share a little bit of demo about how we are actually using the generative AI, with a couple of demos explaining you, like for example, I'll be trying to use a latest tool like Cursor IDE or Visual Studio Code, and some of the things like how you can use this Gen AI to write software code, use it for testing. So I'll try to cover as much as possible within the given time. So if you have any questions, please post it on the chat. Happy to address them at the end of the session. Okay, so let's just go over what is actually a generative AI. So when people most hear about AI, right? Most of them, they picture machines as making predictions, like Is this an email, a spam, or is this a cat? What is the sentiment of the person that has actually tweeted? So honestly, that's how the AI has been for the past 20 years. It's all prediction and classification. But something has recently shifted, which is the generative AI. So generative AI is not just prediction; it actually creates content, new content, such as images based on patterns on previous learning data. So today an AI can actually write essays, generate code for you, even compose music, right? Even design new protein DNAs and things like that. So it's trying to work on the healthcare industry a lot. So if old AI is like an autocomplete for you, consider generative AI as writing the entire novel, including characters, plot twists, even sometimes when you can actually correct your typos. So it does pretty much from writing a novel to writing a code or writing a software. So how is this actually working is because of the underlying transformer architecture. So before transformers, most of the AI models have worked with a language built on something like an RNN or LSTM, which you guys are actually like top, right? So I'm not going to go into those, but those are like human scanning the sentence slowly. But that has made them powerful, but it's also very limited. So they have struggled with long sentences. Training them at scale was actually painfully slow. So Transformers has completely changed the game. The key idea is something called as the attention. So I think most of you guys have heard about the research paper. Uh, uh, so instead of reading words one at a time, what transformers look at the entire sentence as one, and then figure out which words should pay attention to each other. So that's the underlying fundamentals of what exactly the transformer architecture is, right? So, for example, if I consider a sentence, let's say the cat sat on a mat because it was tired. Okay, so in the sentence I said it was tired, right? So previously it didn't know how to refer that it, so whether it is a cat or it's actually a mat, so it doesn't have any difference between them. Now transformers can understand and refer that bird it back to the cat or the mat. So that's the parallel way of making process the transformers faster, more scalable, and much better at capturing the context, right? So that's why the models that you're seeing in the current game, like for example the GPTs, the BERT, or any other all modern Gen AI tools are all built on top of this transformer architecture. So if you think of an old model where reading like a narrow tunnel, transformers is like turning them on the stadium lights. So if you think in that way, now you're suddenly going to see the entire context is actually visible all at once. Yeah. That I'm not going to go into deep around how this transformer architecture is actually going to work and what is all it's actually doing. So I'm not going to go through it line by line. So you shouldn't, but what you should focus on, obviously, the encoder and decoder section that's there, like stacking Lego layers one after the other, and that is actually attention showing up at multiple times in the pipeline. So it's going to get repeated one after the other, right? And that's why every modern Gen AI model you hear about today, like GPT, Claude, Gemini, Llama, everything is actually built on top of this architecture. So I'm just going to talk about these 3 points of tokenization, obviously, which is like any text that you talk about is going to be broken down into smaller tokens that the model can understand. And then you have this attention mechanism. So instead of reading the word one by ones, the transformer is going to look at the entire sentence and which words to pay attention to. Yeah. And then parallel processing, of course. So all these is because all the tokens are going to get processed all at once and not like a sequential thing. So that's how the transformer architecture currently is. Right. So coming to the next big section, now let's talk about something you have already have experienced on. It is the coding assistance, right? I know most of you guys have already familiar with one of the things like GitHub Copilot. So I can just press one if you have already heard of GitHub Copilot or any other IDE tools that predicts your next line of tools. Just press one, please, if you are already across or heard about those tools. Yes. That's fine. No worries. So if you have not heard of Copilot, it's already fine. But Copilot isn't just only one. There are a lot of tools like this, actually. Yeah. So you have Amazon's Code Whisperer. You actually have something like Tab9, and even coding assistant IDEs like Cursor or Windsurf, for example. So there are a lot of tools that is actually available in the market. But the interesting part is each tool has its own philosophy, right? Some focus on pair programming, like Copilot. So if you see the four quadrant that I've put down, it's more of a visual representation of like saying like how many tools that we currently have in the market. I've just highlighted a very few of them. There are actually tons of tools to actually assist you in the software coding. So some of the things like Copilot is actually like a programming assistance for you, whereas you also have something like a Code Whisperer that basically act as a enterprise security assistance, right? So for example, you might actually try something like an end-to-end workflow that I want to push. Something like a Lovable or a Bolt, for example, where it's an end-to-end agent that can actually build an entire application, not actually an applications. I would say it's going to be like a fast prototype agents that we currently have the market. So that's that. Those agents that we currently use in the day-to-day basis. You can actually see them in the news articles, probably in the YouTube channels. These are very famous coding assistants. The biggest takeaway from this is AI assistants are not actually sidekicks anymore. They are actually becoming your teammates. And what they actually do is they can actually generate a boilerplate code for you, which means that you don't have to build things from scratch. With a few lines of prompts, you can actually get the head start. And it can help you with your testing, for example, like generate unit test, and it actually help you to debug something, which is a very common thing. Previously, as software engineers, when I was a software engineer, when I was started as a student, right? When I was a student, I used to struggle a lot with debugging a particular problem. Even now, there are a lot of cases where debugging a particular problem, trying to find where exactly the problem is. It's one of the major challenge. And obviously, the AI coding assistant or your AI agent can definitely help us, in trying to find the actual root cause. And one of the other major use case that I would think of is like, let's say you've joined an organization and suddenly you have given a big piece of code base, where a lot of things and a lot of stuffs are actually pretty new to you. How do I understand the entire code system, right? It's going to be very hard, and there will be people to help you, but they're not going to teach you line by line like how this code is going to work. So that's actually a major challenge for me, especially back in the days. So you can actually, what you can use is you can actually use these coding assistants, AI assistants, explain you some piece of code. And this is one of the main things that I say with my peers, that when you write a piece of software code, it's not something you're actually leaving out for. For example, it's actually, it's not just about how the software works. It's actually you're communicating with your peer human actually. So previously it's used to be like that, because people stay for 2-3 years in one company and then they switch to another company. So now you have joined a new company where someone has already written some piece of code. How are you going to understand it? Like, they might have thought about sequence 1, 2, and 3, and they may not have thought about some other sequence n, right? So explaining those hard, tricky code was very difficult. So that's where, these coding assistants can really help and shine. So getting a quick start on a particular project, or even create documentations. If some of the projects, like for example, back in 2009-10, working on a project where documentation was very hard, right? So we just, developers focus only on writing code, and don't document those things.
Yeah.
So those are the places where, these AI assistants can really help you shine. So here's the catch. So now these are really great collaborators, but they are not 100% perfect. So they really need to review and what they generate. So what, as a software developer, by the way, when these coding assistants generate certain softwares, and when you run the test, or when you understand certain problems, so the major thing that you need to keep in mind is these are not 100% foolproof. So with that in mind, I'm gonna go to the next one, where how the generative AI is actually currently helping the developers in the workflow, day-to-day life. By the way, just going back to that, these coding assistant, right? Some of them are actually has very good free tier, and you can, in one of the major advantage of using GitHub Copilot is actually, GitHub Student Developer Pack is actually available, where you can get a free access to Copilot. So some point in time, just feel free to, maybe as a weekend, try to sign up on these platforms, like for example Cursor, or GitHub Copilot. Just give it a shot, how this are actually helping, how these can assist you. So because they have a lot of free tiers currently, and especially for the student developers pack, they have a very good free usage tiers. Right. So now going to the generative AI as a developer itself, right? So one of the major helpful thing that this agents can do is obviously to work on, help you on the code generation. So when I say code generation, these are not just tabs, auto tabbing, like for example, autocomplete kind of a thing. So if I type func function, and it's going to type, when I press a tab, it's going to complete that word function. So that's not I'm talking about. So I'm talking about generating the actual implementation of the function itself, or the implementation of the algorithm that you really wanted to do. So that's the major code generation help that it can do. And consider it like you have a team of specialists that are working together. So that's called as agentic workflows. So documentation, I think I've already talked about the code generation, debugging, and documentation. So I'm going to go beyond a little bit about just being an agent, just being an assistant, to an agent mode now. So how the agent mode is entirely different from AI assistant is because the agent is actually like an autonomous thing, where it can plan, it can reason, and it can execute tasks with minimal guidance. Okay, so that means they're going to work independently and think through the system of the requirement that you have given, and it's going to produce the output for you. Okay, so imagine this. Instead of one model doing everything, like for example, you have used ChatGPT to generate a certain function, right? I think most of you guys must have done that. So if you're doing something similar to that, the problem of that, using one model, is actually, it's going to create a much more hallucination, because there is a whole lot of requirement that it has to read through. And as you go through the same cycle again and again, it's gonna produce a lot of mistakes. So that's when we are going to split this assistant into multiple modes, which is where the multi-agent systems comes into picture. So consider it like small teams, right? I don't. So if you're really confused, if you're seeing like, oh, what is this? Don't worry. I'm gonna show you a little bit of demo of how to actually do this, so you will feel comfortable when I end this class. Yeah. So you don't. So just going back to that same one agent reading the requirement. Consider it like a team of agents gonna do your job. So you're going to give it some documents or a requirement document. So one agent will read the requirement, the another agent is going to implement it, the third agent is going to do some testing around it. The other agent can review the code itself, and then finally the last agent is going to generate the documentation for you. But as an end user, right, you will be interacting with only one interface. Okay, so the user is not going to see anything like there are multiple agents are actually working in parallel. The user is not going to see anything like that, but that's what actually happens in the background. So why is this important is because this is how we move from an AI as an autocomplete to an AI as an autonomous problem solver. Yeah. So this is the major thing that I'm going to talk about. So I'm going to show you some demo where how you can do a simple test-driven development using generative AI. Yeah. Let me quickly share my screen. I think I'm going to stop share and share it again because I want to share my entire screen now. So bear with me for a second. Cool. I'm going to share my entire screen. I think the entire screen is visible now. Yeah, hopefully. Sure. So one of the hardest, habits is sticking to test-driven development code. So how many of you know about test-driven development, writing test before you write code? Has anyone heard about it? Or it's completely new? One for I've heard about it. Two for no, it's completely new for me. I've never done that. Yes, no. Don't worry, it's okay. I have been like that in the past. So even if you're completely not sure, that's fine. What I'm gonna do is like, so test-driven development is basically like you write test before you write the code. It's very powerful where you actually test or look for what you want rather than implementing your code first, right? But the challenge here is it's very slow and tedious process. At least if you talk to any of the software engineers, probably like your friends or brothers or whoever working in the software domain, everyone will say like testing I will do it in the last. I'll just go and implement it because that's much more simpler, right? But this is where AI is actually going to shine. So what you can actually do is you can use AI to generate the test functions for you, test cases for you. And once the test cases are actually ready and you have reviewed them, then you can actually ask the AI itself to write the function so that the test is actually passing. Let me show what I mean. So I'm gonna show you. I'm gonna use TypeScript just for this particular demo. You can use any language, it doesn't matter. So I'm using Cursor IDE, but if you don't want to use Cursor IDE, you can actually use this in Visual Studio Code as well. So I'm just going to show you how I downloaded Cursor. In case if you're not sure, just Google around Cursor IDE. You should be able to download Cursor for Mac OS or Windows or whatever. It should be available for all the systems. And why I use Cursor is basically a fork of Visual Studio Code. Any of the front-end engineering or TypeScript kind of framework you use Cursor. Just because I have to show some examples here so that you guys can relate. That's the reason I have chosen TypeScript. There's nothing hard, like you have to use cursor or you have to use this particular language or anything to practice this test-driven development with generative AI. Okay, so let's say I have a function. I'm going to go with a very simpler thing that you might have already known about, which is like I have a function that I want to implement where I pass a string and I want to check whether it's a palindrome or not. It's very simple. I mean, I know you can actually write that directly, right? Go ahead and just, so what is a palindrome? Basically, if you reverse a string, it's going to give you the same string back, even if you reverse it. That's what the palindrome means. So I'm just going to implement a simple I need to implement a simple function. Currently, I haven't done that. So that's what I want the generative AI to do for me. But what I have actually done is actually I've written the test, making sure that whatever the generative AI is actually generating is actually validated against my test. So this is actually a very good use case of how to use generative AI, because in this particular example, you're not just testing the generative AI, you are actually creatively thinking about how the real world is actually behaving. So for example, if a client comes with a requirement for you where I want to build a shopping cart website, so you might just say I want people to select certain items and put them in the cart. Like that's a simple scenario. So for that scenario, you want to come up with, write up a test case, like on the UI I need to see the products, and then I want them to select the product, and then I want to validate against the cart that the products are getting added back to the cart. So those are the test cases that you will write for that particular scenario. And then implement the actual implementation, you can actually use the generative. Okay. So considering that big picture, okay, let's just start small for this particular function where I want to check this function, which basically takes a string to be palindrome or not. Yeah. And
So your voice is muted, sir.
oh no, I don't know when it was meted. Where do you guys know where I was? Like, um, or I was just speaking on mute. All right. So you guys got what I was trying to do, right? Like I'm just trying to open up a agent in my cursor IDE, and I'm asking it to write a palindrome checker function based on the test I have written. I'm also asking it to make sure that build and test are passing. I'm not sure when did the button went on mute. So all right, you guys are following, right? Yes. No? Yes? No, please? Can you just type 1 if you're actually following? If not, I will go back to whichever slide I was before the notebook. Okay, you guys are following. Cool. Thanks. All right. I'm gonna hit the send button. Let's just so this is actually happening in real time. So I'm not doing anything. So I'm gonna just wait for this AI to generate the code for me. You can actually see it has written some code and it is asking for the permission to run the test. So let's just give the permission to run the test. Yes, and the tests are passing, which is good. So this is actually good that the tests are actually passing. So it's now going to run the build, and yeah, the build is actually passing. So now it has given me the summary of what is implemented, what are the edge cases. Okay, let's try one more thing. Let's accept the changes that it has done. So basically this is how we work with generative AI. So basically we start with one small task and then build on the other, so that making the system like a Lego pieces. So you build one on top of the other. Yeah. So let's ask it like, can you write a test case with an edge case scenario where string is empty? Right, there is already a test case. Right, let's just say if there is any additional test case that can be covered. Yep. Right, additional test case. Let's just see what's actually doing. Right now it's going to write the test for me. So going back to the multi-agent system here, right? Like if you look at the prompt, I'm actually using the agent mode. So what it means is, nice. So what it means is, it is actually is in the background. What it does is it actually uses multiple agents in the background to validate or write the test. So this best case is failing. So because of the current implementation removes all the alphanumeric characters, which is, so the expected test is to fail itself. So it should actually fail. So let's just see what's going to happen. Yeah, I think it has returned very good test case covering a lot of scenarios here. Like for example, race car, madam, or noon, for example. It has done quite a lot of things here. And it still fails for one of the test case. So let's just, so iteratively we actually ask to fix the test or the function that you have actually written. So which is actually good. So obviously, right, like you can actually see where the generative AI is actually failing. For example, uh, consider a scenario where your requirement itself to remove the non-alpha numeric characters, right? um, but in your test case, you're actually trying to test that particular scenario. It's actually a falsy test in itself. Like so the generative AI doesn't aware, it's not aware of your context at all. Okay, so that is the main thing that you should be aware. So I'm going to talk about the next little thing where I want to show you exactly where the generative AI is going to shine. Have you guys have heard about model context protocol from Anthropic Claude? Um, so what it does is it allows you, the generative AI assistants, to talk to an API, which basically doesn't use actually the actual API. It's called as SSE, but those are kind of endpoints. Um, so for example, if you have a GitHub server, so what is GitHub is actually is where you can actually, it's a repository kind of a thing, where you can actually write some code, or save your code there. Like previously, what we used to do is like after writing the code, we use the Git version system to push the code to GitHub. You can obviously push it to source tree or whatever. So I'm not going to confuse with that. So basically, what all I'm trying to say is you manually used to commit the changes. Like for example, I use git add dot. But basically, this does this. It's going to stage my changes, and I use the git commit command to basically commit the changes. And then if I use git push, it's going to push it to the GitHub repository, right? So this is what it used to do previously. Okay, now what you can do is you can actually, instead of running all these commands, you can actually use AI to push the commit and push the changes, and let the AI do its workflow, right? So that's the main advantage of using an MCP. So that's called as MCP, because what MCP means is it's gonna allow these AI agents to talk to a different server like a functional call. Okay, so you have a function that's going to perform certain actions. Okay, and then your agents is performing certain actions already, right? So how do I make these two to talk to one another, right? So that's how your model context protocol, the MCP, actually comes into the picture. So you have two different functions talking to each other. Okay, that's how I would put it in the simple terms. So I'm going to show you a small demo of how this model context protocol can be used in a real scenario. So this is actually a real scenario that I have used personally in my software itself. So I'm going to show you that. Oops. All right. All right, I've actually have a video of it, so I'm not gonna run you through the full code. So it's gonna be a small 1 minute video. I'll pause in between so that it's easy, right? So I'll go back to the slide a minute, just to say, where is it? Cool. Is it in a full screen mode? No, not yet, but I think you should be able to see my screen. Yeah. So if you look at the right hand side, right, like you can see a browser window. Yeah. And in this browser window, in the left hand side, you are seeing a chat history. Consider this is similar to your chat GPT's interface. Okay. But this is actually my own personal interface that we have developed. So what has actually happened was when we clicked on the left hand side, I was trying to load the chat history. It has bought the chat history back from the database, and it has displayed in the UI. And however, when the user is trying to type something, it was throwing some weird HTTP 400 error. Okay, and then it's showing the thread box. So I want to, so obviously, right, like we are software engineers, so we can just right click and then do inspect, and then we can actually see an error in the console log. That's how most of the debugging will start whenever you're seeing any errors like this. So I gave the context of what the error is actually throwing, where the error is actually throwing. But even if you don't give that particular code block of information, it should be able to use the MCP server to debug this particular issue. Okay, so the MCP server that I'm going to use for this particular demo is called Playwright MCP. So Playwright is like a framework that can actually launch a browser, and you can write scripts to execute them. Okay, so it's a pretty famous across your testing world. So any of the testers in using the modern web applications are actually familiar with TypeScript Playwright server. So what Playwright company did was, okay, let's just build a MCP as a wrapper on top of the API that they already have. Okay, so this is what I did, and to enable the Playwright MCP, what I actually did was in the cursor, you can actually, there is an mcp.json file that you can actually create. So this is a JSON format where you are actually defining the servers that you want to add, MCP servers that you want to have. In this particular case, I have added the Playwright as an MCP server. Okay, and I've started the MCP server, so automatically it will start if you put anything into the mcp.json file. Okay, and let's see. So what I'm currently doing is I've asked it to use the Playwright MCP and find out where could be the issue. The dev server and the backend agents are already running in the terminal, so it doesn't have to do anything, and there are data test IDs to traverse through the flow. So I'm not asking it to fix anything. Okay, that's the important thing. I'm not asking it to fix anything. I want to identify the issue or the root cause first. Okay, so that's the main thing, that's the instruction that I'm actually giving. So it's all about context that you give to the AI. Okay, so as you can see, as I press the send button, right, the agent is smart enough to trigger the MCP Playwright MCP server and is able to launch the exact website that it is aware of. So you can see that it's currently launching that website that has the error in my local. That's why you're seeing the local host. And let's see what it's actually doing. It's going to log in with the current test credential that I gave. And obviously, this is something that I don't want you to do it on any prod environment. I'll talk about do's and don'ts in the next slide. But this is more of a demo, test users and test user accounts. So it's safe to give that there. And you can see that it's able to get this, retrieve the chat history. That's what I said earlier. Once the history is actually ready and the user is going to type something in the chat window, and that's when it got the error. Yeah, and it's able to reproduce the error. And let's see what is actually done. If you see the logs, it's gonna say I've clicked this, I'm doing that. Perfect. I can see the chat history. It's doing all of those as it's currently doing. It's going to log everything step by step so that you can actually read through what it's actually doing, right? And then it has identified, and it is also clearly saying that I have able to replicate this issue, which is very good. And it's also able to find out the exact root cause where the validation schema that is being sent is actually wrong, and it's actually able to pinpoint the exact endpoint where the error is actually coming up. It's reading the actual it's reading the actual implementation file, and it's actually checking all the URLs. So you can actually clearly see that where is the issue, right? So for example, the URL is having a different ID, and the ID that is expected by the backend is actually different, and that's causing the mismatch. So it has actually found out where the problem is, which is very super useful. And this is one of the very useful scenario, or very useful use case that you guys can actually try. You can actually start up your own server. You can actually use build your own projects, and then you can use Playwright MCP server to play around with it, get familiar with those. Yeah. Cool. Are you guys able to follow? Then we are good. All right, I'm going to go to the next slide. Obviously, I'm going to talk about the do's and don'ts here. The do's are actually review the code that is generated by the generative AI before your deployment. And the major to-do that I want to talk about is never share your environment variables, or never share your secrets, like for example your OpenAI API keys. Okay, don't put that into your chat context window. Okay, never do that. So I want, since I'm actually sharing my screen, I can actually show you that there is actually something called as cursor ignore. Okay, so this since I'm using cursor IDE, I'm showing you this cursor ignore file. Similar to this file, you already have similar files, like what the AI agent should read and what the AI agent should not read. So as part of that, cursor ignore is one of them, where I want cursor to ignore these files from my workspace. So for example, the .env file is one of them, which is where all my secret API keys lies. So I don't want it to read it, even for the dev environment, right? So we don't want to read those. And as the generative AI is going to be a big thing. The context is the major one here. So there are rules you can set for this agent. Like for example, what is the development standard that you need to create? So for example, I want to create these variable names with these names, and I want to have an hyphenated words. So those are sort of requirements that you can set, or standards that you can set in the cursor rules. So this is, so I'm going back to cursor rules because I have that as an example here. Obviously, you can do this in GitHub also. So in GitHub, you can see Copilot instructions I have given. Okay, so which means that you can actually do the how the GitHub Copilot should read your entire workspace. Okay, all the instructions are actually given in one file. So each instructions for the IDE is actually different. So make familiar with those, and obviously those are going to be your tools. So if you are creating an art, then you need to be familiar with your tools to create as an artist, right? So similar to that, if the AI tools are going to be your tools that you want to create an art for it, then you need to be sharpening your tools. So that's why I'm saying these rules folder that exist. And yes, that's pretty much around the demo itself. So I'm going to go over the actual use case or a case study at AI Alchemy, what I'm currently doing. So what we are currently doing is we have taken up the idea of agentic workflows, and we are actually building something like a multi-agent system. So what multi-agent system feels like is you are actually chatting to a single chatbot. Like for example, in this case, right? So you're actually chatting to a single chatbot. However, there is a team of assistants that are actually working together in order to solve your request. Okay, so for example, the good example is like your personal assistant that we are actually working on. That's gonna delegate the job to the series of agents, like for example, the events agent, the online search agent, and weather agent, for example. And all these agents works in parallel, or it can work in sequence depending on the question or the request that the user has asked for. Okay, and then finally the aggregator or the agent core is going to combine all the analysis and then give the final output back to the user. Okay, so what we are currently using as a protocol to how the agents are actually communicating is actually there are a lot of open source, actually closed source frameworks, but what we have chosen is the Google's agent to agent protocol. So this is how they communicate with each other. It's like a Slack or your Teams for the agents to talk to each other. Okay, so it's a standard way of communication between two agents. It's called agent to agent protocol. That's an emerging thing where it's actually open source, so you can actually look at the actual source code itself, right? And so with this, the bigger point here is the AIs are no longer a single chatbot. It's going to be an ecosystem of specialized agents that can work together just like humans do, right? And that's what we are building in AI Alchemy. So, and the future, like what you guys are actually doing, right? We are actually looking for so generative AI that started as an autocomplete has now become fully assistants, and they are evolving as a team of agents. So what's the next big thing that's currently happening is, or already happening, is basically the sovereign UI AI that I want to talk to a little bit about, which is where every country is actually looking for, where countries like India, Australia are all actually, we are trying to build our own AI models. It's actually a good way because we don't want to rely specifically on big tech companies. So imagine a future where every nation or every university, sorry. So this is where you have all your so it's going to be having your AI tuned into its own needs and culture and values, right? So that's the other thing. And then you have the open source revolution, where the projects like Llama, Missile, Hugging Face are all producing a lot of world-class AIs. Yeah. The bottom line is you're not just going to be the future coders. We will be the AI collaborators, right? So AI empowers the software engineers by elevating their code to one of the strategic decision making, meticulous context engineering, and crucial risk management through verification, while agents can handle the heavy lifting of coding, testing, and monitoring. So with that note, I'm gonna stop here. And if you have any questions, thank you for being patient and listening to me. So thank you so much. I'll wrap up here. Yeah, feel free to ask any questions. If you have any questions, please feel to ask. Yeah.
Thank you very much, sir, for your deep insights. We will now move on to the question and answer session. I invite students and faculty members to interact with our guests and seek clarifications.
Sir, can you explain about MCP, sir?
Okay, so MCP is like the modern context protocol. Okay, so what it does is consider like you want to. Okay, so if you want to have two agents or two systems that want to talk to each other, that's when we use MCP. So this gonna power up your LLMs to perform the workflow actions for you. Like for example, you can use MCP to trigger a browser window. Okay, and then you can use MCP to traverse through the website, book a restaurant for you, and you can do all sorts of things just using your MCP protocol. Does it answer your question?
Thank you, sir.
As we come towards the conclusion of today's program, let us now welcome R. Darshan from second year to deliver the vote of thanks.
Good afternoon, everyone. As we come to the conclusion of this wonderful session, it is my privilege to deliver the vote of thanks. First and foremost, I extend a heartfelt gratitude to a guest speaker, Mr. Srinivasan Jayaraman, sir, for sparing his valuable time and enlightening us with his knowledge on generative AI and its role in modern software development. Your words have surely ignited curiosity and inspiration among all of us. A sincere thanks to our principal, Dr. Kumar, for his constant encouragement and support. Our special gratitude goes to our convener, Dr. P. Srinivasan, sir, professor and head of CSE AML department, for guiding us in organizing this workshop successfully. I also thank our faculty coordinators, the student coordinators, and all the participants who made this event meaningful with their active involvement. With this, we conclude today's workshop. Thank you all, and we look forward to many more such enriching sessions.
Thank you.
Thank you, Darshan. Thank you all. Students are kindly fill the feedback form. This is available in the chat. Students are allowed to fill the field, but feedback form is allowed in the chat.